Hello friends, this video is brought to you by www.moateaching.com.
Let us now draw graph of quadratic polynomial and understand the geometrical meaning of a zero of a quadratic polynomial. We will check if the zeros of quadratic polynomial are the x coordinates of the point where the graph of fx, that is the quadratic polynomial, intersects the x-axis. Let us take a quadratic polynomial, say fx equal to x square minus 3x minus 4. We write it as y equal to x square minus 3x minus 4. Now corresponding to different values of x, let us find the values of y. Say we choose the values 0, minus 1, minus 2, 1, 2, 3, 4 and 5. Substituting x equal to 0, we get y equal to minus 4. Similarly, for x equal to minus 1, we get y equal to 0. For minus 2, we get y equal to 6. Likewise, complete the table. It is now time to plot these points on the graph. We have the coordinates written and we start by plotting minus 2, 6, minus 2 on the x coordinate and 6 on the y coordinate. Similarly, let us plot all the points. Once we plot the points, let us join them. The graph so formed is called a parabola. We can see from the table that for x equal to minus 1, y is 0. That means minus 1 is the 0 of the polynomial. Also for x equal to 4, fx becomes 0. So 4 is also the 0 of the polynomial. And from the graph, we can check that the zeros of the polynomial are the x coordinates of the points where the parabola intersects the x-axis. We observed that graph of quadratic polynomial is a parabola. Also notice that here the graph opens upwards. This is because coefficient of x square in the given polynomial is positive. Here coefficient of x square is 1, which is a positive real number, so the parabola is opening upwards. Suppose if the coefficient of x square was negative, then the parabola would open downwards. The given polynomial fx equal to x square minus 3x minus 4 has two distinct factors, that is x plus 1 and x minus 4. So the parabola is cutting x-axis at two distinct points, that is minus 1, 0 and 4, 0. But this may not be the case for all the quadratic polynomials. For example, consider a polynomial, say hx equal to x square minus 6x plus 9. Let us factorize this. It comes out to be x square minus 3x plus 9, x common, x minus 3 common, x minus 3, and the roots or the factors of this quadratic polynomial are same. This implies that 3 is the only zero of this polynomial and the parabola of this polynomial touches x-axis at only one point, that is 3, 0. Let us look at the possibilities of the graph of a quadratic polynomial y equal to ax square plus bx plus c. First case would be when the quadratic polynomial has two zeros, then the graph will cut x-axis at 2 points. It can be any of these. Second case is when the zeros of the quadratic polynomial coincide, that is, both the zeros have the same value, or in other words, there is only one zero of the quadratic polynomial, then the graph will touch x-axis at only one point. Roughly, it would touch only at one point, say A, or it would be something like this, just touching at one point A. And the third case is when the quadratic polynomial has no zero. Then the graph is either completely above the x-axis or completely below the x-axis, and it does not touch x-axis at any point. So we can see that the quadratic polynomial can have either two distinct zeros or two equal zeros or no zeros. This also means that a polynomial of degree 2 has at most two zeros. If we want to find out without factorizing whether the parabola will touch x-axis at 2 points or 1 point or none of them, what we need to do is we calculate d, which is equal to b square minus 4ac. If this d is greater than 0, then the parabola cuts x-axis at two distinct points. If d is equal to 0, then the parabola will touch x-axis at one point, and if d is less than 0, that is if d is negative, the parabola does not touch the x-axis. The point at which the parabola turns is its vertex, and we can find the coordinates of vertex of parabola from the coefficients in the given polynomial by substituting in x coordinate of the vertex will be minus b by 2a and y coordinate would be minus d by 4a. Both these results will be very useful while drawing a parabola. We have seen that graph of a quadratic polynomial is always a parabola, either opening upwards or opening downwards. Here we will see that graph of a cubic polynomial does not have a fixed shape. We will also notice that graph of cubic polynomial will always touch x-axis at least at one point and maximum of 3 points. Let us take an example and draw the graph of a cubic polynomial, say fx equal to x cube minus 4x. This can be written as y equal to x cube minus 4x. Now draw a table. Let us take some values of x and find the corresponding values of y. For x equal to 0, substitute here 0 cube minus 4 into 0 gives us 0. Similarly, for x equal to 1, we get y equal to minus 3, x equal to 2, y equal to 0, x equal to minus 1, y equal to 3, x equal to minus 2, y equal to 0. So here we have 3 zeros of the polynomial x cube minus 4x, namely minus 2, 0 and 2. As we are getting f of minus 2 equal to 0, f of 0 equal to 0 and f of 2 equal to 0. Now let us plot the points on the graph. We plot all the points and now let us join them. From the graph we observe that the graph of y equal to x cube minus 4x intersects the x-axis at 3 points, which are also the zeros of the polynomial y equal to x cube minus 4x. So the result holds for a cubic polynomial also, and the zeros of the cubic polynomial are the x coordinates of the points where the graph intersects the x-axis. Let us now look at another example of a cubic polynomial and try to draw its graph. Say we take y equal to x cube. Then corresponding to x equal to 0, y equal to 0, x equal to 1, y equal to 1, x equal to 2, y equal to 8, x equal to minus 1, y equal to minus 1 and x equal to 2. If we take x equal to minus 2, then y equal to minus 8. Let us plot the points. After plotting the points, let us join them. We observe that the shape of this cubic graph is completely different from the previous one. Also note that 0 is the only zero of the polynomial y equal to x cube, and from the graph we can see that 0 is the x coordinate of the only point where the graph of y equal to x cube intersects the x-axis. As the graph of a cubic polynomial here is touching x-axis at only one point, we come to the conclusion that graph of a cubic polynomial will touch x-axis at maximum of 3 points, or it will touch at less than 3 points. In general, given a polynomial px of degree n, the graph of y equal to px will touch x-axis at most n points, as the polynomial of degree n has at most n zeros. That means maximum of n zeros. Like here, cubic polynomial can have at most 3 zeros or less than that.